Hello, is this working? I'm not sure because it doesn't normally start this way, but I'll have a check. It looks like it's working. Right, okay. I'm just going to get something or get stuff set up quickly. Um, and then we will make a start if anybody has joined us. I'm just, yeah, getting stuff set up. 1 second. Making sure I've got everything sorted. So, pretty much there. The only other thing I want to do is probably move me over a little bit, and then what else was there? There was something else I was going to do, and I've forgotten now. Ah, it doesn't matter. I'll remember later. Anyway, right. Anyway, so we're going to make a start. And just oh no, I do know what I need to do. I need to get the chat so I can see it. So I'll just sort that now. Let me pop this out. Uh, just in case anybody comments. So, going to be working through this paper, June 2023, Further Maths AQA GCSE past paper. So this is the non-calculator one, which I believe, unless I've made a mistake, is tomorrow morning. So I wanted to go through the non-calculator one specifically for that reason. Right, so we'll make a start. I've got till about 7 o'clock, and I'm hoping I should be able to get through all of this. So what I'm going to do is just try and make it so that I've got the width of the screen on there. So like that, make this a little bit bigger, make sure my head's not blocking it. There we go, that'll do anyway. I can just move my head out of the way or make me a bit smaller. Perfect, there we go. Right. So, let's crack on. Right, so the function f is given by f of x equals 2x plus 1. Work out the value and f of x is equal to minus 5. So 2x plus 1 is equal to minus 5. Take away 1, we get minus 6. Divide by 2, we get minus 3. Okay, so that is the value of x that would give us minus 5. Next question, we've got f of g of 3. So for that, we are going to put 3 into g first of all, and then into f. Okay, right, so we are going to do 3 squared, okay, and then we're going to do 2 times that plus 1, because it's almost like you've got brackets here. Okay, so 3 into g and then put your answer into f. So 2 times 9 plus 1, 18 plus 1 equals 19. Okay. Right, moving on then to the next question. Factorise fully, you can see here we've got obviously numbers in front, so we're going to find the biggest or the highest common factor of both of those. So that's going to be 3. I might as well just put this on the answer line, do it all in one go. So 3, and then we've also got x and y in both. So 3xy, and then it's going to be 2x plus 7. Okay, can't factorise anything, or can't factorise anything out of the stuff inside the bracket, so it must be fully factorised. This one, circle the transformation that represents a reflection in the line y equals minus x. Now, if you forgot this, or how to do this, then the way that I would remember this, to move this to the side a little bit so we've got a bit of space, is the line y equals negative x. I'll do a quick sketch here. That goes this way. Okay, now if you just think about a point on your y-axis, okay, so this point here, if we reflect that in the line y equals negative x, that goes onto the x-axis, okay, and becomes negative. Likewise, an x-coordinate, a point on the x-axis would go to the y-axis, so the same number but become negative. So that's what we're wanting. We're wanting positive x and y to go to negative x and y. So if we had as a vector 1, 0, 0, 1, so that would be 1, 1 over here, we want to go to minus 1, minus 1. Okay, so we want our x to go to negative y. We want to end up with 0, minus 1, and then we want our y to go to minus x, like this. Okay, so we want our 1x to go to minus 1y and our 1y to go to minus 1x. So to get that, what we need is the only one basically with minus 1's in, it's this one. Okay, so it's going to be 0, minus 1, minus 1, 0, because when we multiply, we do 1 times 0, so this one here times by this one, so 1 times 0, 0 times minus 1 gives us the 0. 0 times 0 minus 1, sorry, 1 times minus 1 gives you the minus 1, and so on with this other side. So yeah, this is our answer here. But that's probably how I'd work that out if I'd forgotten which of these is the correct matrix for the transformation. A reflection of line y was minus x. But I would just suggest learning those. This one here, so the way that you multiply matrices, if anybody has forgotten or is not sure, because it is a new topic at GCSE or IGCSE, we're going to take this one and we're going to multiply it by this, and that's going to give you the value where they cross over. So they're going to cross over at this one if I laid them on top of each other, so that's where our answer is going to go. So basically I rotate the left hand side, so I rotate the 2 and the 4 and then I multiply them. Okay, so I'll do 2 times minus 3 is minus 6. No, there's no way of knowing what topics are 100% coming up on tomorrow's further maths paper, but you can make some predictions of which topics are definitely, if they're going to come up on any paper, which topics will come up or have to come up on a non-calculator. So, you know, things like I'm going to cover today in this past paper. So things like probably your matrix transformations, things like exact trig values, and there'll be some other topics which I'll point out today when I'm going through the paper. But you can't say for sure they're going to come up on paper 1 because they might not come up at all, basically. But if they come up at all, they come up on paper 1, like exact trig values, because you can't put that on a calculator paper because you can just use your calculator. So things like that. Right, carrying on with this, you do 2 times minus 3, which is minus 6, and then you do 4 times 1, which is 4, minus 6 add 4 is minus 2. Okay, now we are going to do minus 1 and minus 3 times by minus 3 and 1. Minus 1 times minus 3 is 3, minus 3 times 1 is minus 3, add them together we get 0. Okay, and that makes sense because we want something times by the identity matrix, which is 1, 0, 0, 1. So if I've done this right, the rest of this should be 0 minus 2. It should be the same thing. So let's have a go. Now we are going to do 2 and 4 times by 4, sorry, minus 4 and 2. 2 times minus 4 is minus 8. Add 4 times 2, which is 8, gives us 0, which is what we were hoping to get. Now the next thing, hopefully this gives us minus 2. So we've got minus 1 times by minus 4, which is 4, and minus 3 times by 2, which is minus 6. 4 minus 6 is minus 2. So we get minus 2 lots of the identity matrix. Okay, so K should be minus 2. Okay, moving on then to the next question. Scroll this down, zoom it out a little bit. Oh, that's the cursor. I was trying to clean the screen and then I was realising that was the cursor on the screen. Anyway, silly man. Right, we've got here, scroll it up a little bit, S, which is 7 and 2, and T, which is 5 and minus 4, are points on a straight line, work out the gradient. Okay, so this should be really straightforward for anybody doing further maths. You do y take y, 2 minus 4 over x take x, but it's got to be in the same order. So 2 take away minus 4 is 6, 7 take away 5 is 2, so that gives us an answer of 3. Really straightforward. Part B, work out the distance between S and T, give your answer in the form A root B. So working out the distance, we're going to do Pythagoras. I'll just write them down here again. So S is 7 and 2, and t is 5 and minus 4. Double check that, 7, 2, 5 minus 4. So distance, going to do Pythagoras. So basically the distance between your x squared, okay, and square root plus the distance between your y, which is 6 squared, okay. So 2 squared is 4, plus 6 squared, which is 36. So we get 4 add 36, which is root 40. Okay, we need to write it like this. So that is going to be, well, 4 times 10 is a bigger one. We can do 8 times 5. None of those are square numbers, ignore me. So 4 times 10, that is going to be it, I think. 4 times 10, because there's no square number that goes in a 10. So that would be 2 root 10, okay, is our answer, because there's no, like I say, square number that goes into 10. Okay, moving on then to the next question, question 5. So, this is an interesting looking question. Xn and Yn are nth terms of two sequences. Prove that every term of the sequence with nth term Yn minus Xn is a multiple of 3. So the first thing I want to do here before I subtract these two things, I'm going to expand them. So that gives me n squared minus 1, and this one gives me n squared plus 3n plus 2. And now I'm going to subtract them. So I've got n squared plus 3n plus 2 minus n squared minus 1, which gives us 3n minus 1 is plus 1, so plus 3, which equals 3 brackets n plus 1. Therefore, 3 dots, every term, and just copy and paste the question basically, of the sequence with nth term Yn minus Xn is a multiple of 3. Okay? Right, I mean that kind of question is something that could come up on any of the papers. If I just have a quick scroll back, 4B probably come up on a non-calculator paper, like paper 1. 4A, doesn't really matter, really straightforward. Question 3, probably going to come up, I would say more likely to come up on the non-calculator paper, because I believe, although I haven't ever used it myself, there are some calculators that can do some work with matrices. So maybe they put that, or more likely to put that on the non-calculator. Question 2 doesn't really matter. Question 1 doesn't really matter again. Okay, carrying on. Right, we've got this. The equation of a curve is y equals x to the power of 6 plus 4x squared minus 7. Work out the equation of the tangent to the curve at the point 1 minus 2. Give your answer in the form y equals mx plus c. So probably non-calculator paper, because you can have some graphical calculators that would or might be useful for this type of thing. Right. So work out the equation of the tangent. So to get the gradient, first of all, we need to differentiate. So dy over dx equals 6. I'm thinking of the power already. 6x to the power of 5 plus 8x, and then the minus 7 disappears. Now we need to put in the point 1 to find the gradient at 1. So dy over dx, where x is equal to 1, gives us 6 lots of 1 to the power of 5, which is 6, plus 8 lots of 1, which is 8, gives you 14. Because 1 to the power of 5 is 1, times 6 is 6, 8 times 1 is 8, 6 add 8 is 14. So from there, we've got y equals 14x plus c. We're going to plug in our numbers. So minus 2 is equal to 14 times 1 plus c. Minus 2 is equal to 14 plus something. We get minus 16 is equal to c. So y is equal to 14x minus 16. Okay, so that is the answer to that question. Okay, Right, so the next thing that I'm going to do, so I'm just quickly having a check of something, that's fine. Right, interestingly, on the mark scheme for question 5, there isn't a statement that is needed at the end of the proof, so all you need to do is end up with 3 brackets n plus 1 at the end. I thought that was quite interesting because quite often with proofs you need a statement, but seemingly with something like question 5, which was this one, the statement isn't necessary. Literally all you need to do is that first line. Which, yeah, like I say, is interesting. It's unusual as well. Right, okay. Moving on then to the next question, question 7. Looks like a bit of an interesting question, this one. So we've got the diagram below shows a cone and a prism. All measurements are in centimetres. The cone has base radius r and perpendicular height x. The prism has a triangular cross section with base y and perpendicular height y. The length of the prism is x. So any predictions? It's hard. Does it not say tangent? Yes, so tangent is just the straight line. Okay, so it's just the straight line at the point on that curve. So that is a straight line at the point with that gradient on the curve and the y-intercept. So it is just that. Any predictions for tomorrow? In terms of predictions, I said earlier in the stream, it's difficult to make predictions because you haven't seen paper 1. However, in terms of predictions, things that are more likely to come up are things that they can't put on the calculator paper because then you could use your calculator. So things like exact trig values. Some other things, maybe like surds, where they want you to show you're working out. If we have a quick look through the rest of this paper, might be things. Algebra they can put on either. So surds again, they want to see you working out for that. Oh right, I'm very glad to hear who short guy your name is in the chat. Yeah, I'm very glad to hear that they were useful. And you know, hopefully, I'm sure it has gone very well with your GCSE maths. A level further maths in September will be really good. Yeah, so I hope you enjoy that as well. It's really enjoyable. It's different to when I did it. So here we go. Different to sorry, jumping around. Different to when I did it because when I did it, they were like it was all modular. So I think I ended up doing like 12 different papers. So it's probably a bit nicer now because you've just got well less than that, a few papers maybe for further maths and then a few for maths as well. Okay, right, so going back to what I think is going to come up on the paper, or more likely, exact trig values, almost certainly going to come up. Make sure you know them. Surds, make sure you're good with surds. Algebraic fractions could come up on either. Same with inequalities, that could come up on either. Index laws likely to come up. If they're going to come up on either paper, I would put them on paper 1. Binomial expansion, more likely to come up on paper 1, I would suggest. Again, we've got another quadratic or cubic, I should have said polynomial, a cubic equation here with a stationary point differentiation. Simultaneous equations, again likely to come up, or more likely to come up on paper 1 because you can use your calculator for those. Completing the square. I don't think that's really matters which paper that will come up on. Circle theorems again won't matter so much. But essentially, what I would do with this is just practice as many paper 1s as you can, which is why that's what I'm doing for the stream today. Because you will get used to the types of questions that come up on paper 1. And what I could do if I've got time at the end, I've got till about 7, can't go after 7. We could go through just different paper 1s, what comes up, what are the most common types of questions. That would be the best way I would do it. What's like the maximum Pascal's triangle power they would make us do? Probably like 6, to be honest. They're not going to just do like 23 because you'd be there for ages. So yeah, I reckon probably like 6. Yeah, I'm not going to go any higher than that. You know, if only just to not make that joke. But yeah, Yeah, probably about 6. Right, let's get back to this question, and then I'm going to try, see how many questions we've got actually. I'll try and get through this paper as quickly as I can, so I've got more time to just chat or go through any other questions that people want to go through. So it goes up to question 20. I'm 20 minutes in. You want to be getting through the first bits of this paper quickly, really, so that if there's any problems, you can go back to them and go over them. Spend more time on them, basically. Right, going back to this question, we've got this prism, we've got this cone. It says, it gives you the volume for the cone, which is interesting. And also, just to double check, I know I'm scrolling a lot here, but at the start of this paper, it doesn't give you any formulas. So, like it's done on this question, if you need a formula, it's going to give you it with the question. I would make sure that you know all the same formulas, probably that you need to know for your GCSE. However, there might be something available online like there was with the IGCSE paper. Just type in formulas I need to know for AQA further maths. There'll probably be something that's made by someone else which is useful as well. Right, let's do this question. The volume of the cone is 4 times the volume of the prism. Express R in terms of Y. Okay, what that tells me is we're going to need to basically substitute in for X. To eliminate the X, then we just have R and Y left. Right, so let's do the volume of the cone. That is 1/3 times pi r squared, the area of the base, times by the height, which is X. Okay, and then the volume of this prism is going to be basically the area of the cross section, so y times y, and then half it, so half of y squared times x. Okay, so now what we've got to do is we've got to write it. The cone is 4 times, so 1/3 pi r squared x means equals 4 times the volume of the prism, which is 1/2 y squared x. Okay, right, now I said substitute in. We don't need to actually, we can just divide by x and cancel this x out here. Okay, so 1/3 pi r squared equals 4 times 1/2 is 2y squared. We need r in terms of y, so we need to have r equals here. So I'm going to times everything by 3 and get pi r squared equals 6y squared. I'm going to divide by pi to get r squared is equal to 6 over pi y squared, and then we're going to square root. So I get r is, well, square root of 6 over pi times by y. Okay, so square root 6 over pi y. Okay, should be our answer to that question. You can leave it in different formats, but yeah, that's how we do it. Okay, moving on to the next question, question 8. We've got a circle with centre 0, 0, radius 5. Let's first of all write down the equation for that. So that is x squared plus y squared equals 5 squared, which is 25. Okay. Straight line has this equation. Work out the coordinates of the 2 points where the circle and the straight line intersect. Do not use trial and improvement. Okay, so you can't just use trial and error to find out these values. You've got to use algebra. You've got to show you're working out. So what I'm going to do is I'm going to divide that by 2. Do I want to do that? No, I'm going to take away the 5. I want to get 2y minus 5 equals x. The reason I've done that is that I don't have a fraction and I can just substitute straight in. Okay, so I either wanted y equals 1/2 x plus 2.5, which is fine, it's just going to be a bit messier because you've got decimals. This one doesn't, it's got whole numbers, which is better. So let's plug that in. 2y minus 5 squared plus y squared is equal to 25. Okay, so squaring this, we're going to get 4y squared minus 5 times 2y is minus 10y. We've got 2 of them, so that's minus 20y plus 25. That's quite nice, we've got the plus 25 plus the y squared from here equals 25. So 25's cancel. We get 5y squared, 4y squared add y squared minus 20y is equal to 0. So we're going to take out 5 and y from both of these things to get y minus 4 equals 0. Let's just double check that. So 5y times y is 5y squared, 5y times minus 4 is minus 20y. So we get either y is equal to 0 or y is equal to 4. Okay. Now if we plug that in to this here, 2y minus 5 is x, we get 2 lots of 0 minus 5 is equal to minus 5. So x is minus 5. Or we've got 2 lots of 4. Oh, go away. Sorry, I've got to pop up again. There we go. Right. 2 lots of 4 minus 5 is 8 minus 5 is 3. So x is 3. Okay, so we've got y is 0, x is minus 5, and y is 4, x is 3. Now, actually, I would check this. However, one of these coordinates already gives away that it should work. So here, y is 0, x is minus 5 has to be a point on the circle. Okay, because this circle is going to cross at 5, 5, minus 5, minus 5. Okay, so I know that circle goes through that point, so I'm very confident that's the right answer. Okay, now one thing to say as well with that is you will want to just write these down as coordinates, like on the answer line here. But obviously, if it doesn't have this and it just has an answer line, make sure you put your x's and y's together correctly, so it's clear which one goes with which. Okay. Otherwise, you may lose marks. Okay, so minus 5, 0, and 3, 4. Okay, right, moving on then to the next question. Rearrange to make y the subject. This should be a fairly standard question, and something that could come up on your GCSE. The only difference is here we've got y squared on the top and the bottom. Okay, so just be aware of that. One thing you definitely can't do is go like this, which some people seem to think you can. Definitely can't do that. Right, just going to have a quick check to see if I've missed anything. Okay, right, yes, that's fine. Just checking that we actually have got people watching, because it's always nice to know there's some people watching. It's not me talking to myself. Anyway, sorry, carry on with this. So we're going to multiply by the denominator. So w y squared minus 2 equals y squared plus 5. So expand that, we get wy squared minus 2w equals y squared plus 5. Now, like with a simpler version of this problem where it's just just y on the top and the bottom, we need to get everything with y in it on one side and everything without y on the other side. So I'm going to add 2w to both sides. wy squared equals y squared plus 5 plus 2w minus the y squared from both sides. We get, I don't know why I put it there, to be honest, because I probably should have put it over here. That gives us wy squared minus y squared equals 5 plus 2w. Factorise out the y squared, so we get y squared and w minus 1. My w's are really not good, I apologise for that. Looks like a stretched out U shape, some of them. Is equal to 5 plus 2w. We're going to divide by that, so we're going to get y squared is equal to 5 plus 2w over w plus 1, and then we're going to square root. So y is equal to the square root of 5 plus 2w over w minus 1. Okay, so yeah, that's our answer to that question there. Right, okay. Next question, question 10. Rationalise the denominator and simplify fully. Now we need to times top and bottom here by the conjugate, and to be honest, this is a question I would expect people to be able to do on their GCSE. So getting this on your GCSE is very nice. So we've got to treat these like they're in brackets basically and multiply it out like it's double brackets. On the top, 1 times 3 is 3, 1 times root 5 is root 5. Root 5 times 3 is 3 root 5. Root 5 times root 5 is 5. Now on the bottom, we're going to get 3 times 3 is 9. 3 times root 5 is 3 root 5. Minus root 5 times 3 is minus 3 root 5. Minus root 5 times root 5 is minus 5. Okay. Now the whole point of this rationalising the denominator is so that we don't get a surd, something with a square root, in the denominator. And as you can see, these cancel. So that gives us, on the top, 8 plus 4 root 5 over 9 minus 5, which is 4. So simplifies to 2 plus root 5. Okay. Which is the answer. Okay. Now, obviously, like with my other papers, if you watch me, I'm doing these all as I would do them because, well, I want to talk you through how to do them. I think that's important. I think it's also important not just to check the mark scheme in advance and just kind of regurgitate that. That's not really helpful to anybody. You could do that yourself. And I want to try and explain, like I do, you know, I'm a teacher, when I teach, actually what I'm thinking when I see a question, because quite a lot of the time that's important as well. You know, sometimes you'll see me reading a longer question and I work out bits as I'm going. Those little things make it easier. I see this question and before I've even read it, it's a polynomial. I'm thinking differentiation, okay? Because I can't do anything else really with a power higher than 3, or even really 2. Predicted paper, okay, and I said this earlier, so I'll just repeat what I said kind of quickly. It's a bit difficult to predict paper 1 because there are topics that can come up on paper 1 and paper 2. However, there are topics that are, well, basically can't come up on paper 2 because you could use your calculator. So things typically, well, the main one is exact trig values. You've then got things like surds, which they want to see working out for. You can't just put that in your calculator because you don't have it. Things like differentiation and polynomials. Some of those things you could put into graphical calculators. So it's difficult to do a predicted paper because there are some things which I'm very confident are going to be on there. Exact trig values, make sure you know them. Make sure you know your surds. Make sure you know how to differentiate, things like that. But they could obviously put things on the non-calculator paper that they could put on the calculator just with easier numbers. So yeah, I haven't done any predictions for paper 1, but I will do for paper 2. Okay. Right, this one, differentiate, find the positive value. We differentiate twice because it's d squared y, put it equal to 55, find the x values, take the positive one. Here, the power comes down the front and then you take 1 away from your power. So 4 times the 12th is 1 over 3. Okay, x cubed. This is dy over dx. And then we have got 3 times 2, which is 6. Take 1 away is 1. And then the plus 4 disappears. D squared y over dx squared gives us 3 times a third, which is 1. X squared plus 6. So we've got x squared plus 6 equal to 55. Take away the 6, x squared is equal to 49. Square root, we get x is plus or minus 7, but like we said, we want the positive value, so x is 7. Okay, pretty nice problem. And one thing that I was thinking while I was doing that is actually, if we do have a problem like this, and I end up getting something which isn't a whole number, I'm thinking I've probably done it wrong. Okay, or if I'm getting a quadratic, which I'd have to use quadratic formula. You can do that, obviously, but it'd have to be nice numbers to work again, all right? So if I was getting something here which was not nice, was going to be a decimal, I was going to have to do some levers like some surd, I would be dubious, very dubious about my working out and want to check it. Right, 12a, write down the value of x for sine x being -1. Now, if we think about our curve here of sine, so this is another topic which could come up. You know, these types of questions with exact trig values. Sine x of -1. So, yeah, basically you need to know your sine, cos, your tan graphs. Sine graph's going to be something like this. Well, not exact, that's a sketch. 360 there, 180 here. Okay, this would be 270, which is what we need. -1 here, 1 at the top. Obviously, this is 0, this is 90. So, the value would be 270. Okay? Yeah, there might be a few numbers on it, but yeah, you'd think nice numbers typically, like I was just saying. But yeah, there's definitely going to be a few numbers on it as predictions. That's a pretty good prediction, I would say. Right, next one. The values of y for which this is true. So tan y is equal to, well, we're going to rearrange it. Tan y is equal to 1 over root 3. Okay, now you can kind of, knowing your graphs, whittle this down to certain intervals, but you do need to know your exact trig values. So this is my tan graph, goes up like this, goes up like that. Got another asymptote here, goes up like this. So that's 360. Okay, this is 270. This is 180. And this is 0. This is 90. Okay, so we're looking for the values of y for which we get tan y is 1 over root 3. So we're going to have one between 0 and 90 and one between 180 and 270. Okay, basically just add our answer onto 180. Now to do this, exact trig values, what I do is there's a hand trick that I use to remember them, because when I was at school I never had to learn them, to be honest, and then I did the national GCSE, but since then I believe you've had to learn them, and obviously I didn't do this further maths paper when I was at school either. So the hand trick, if you don't know, you can watch a video about it. So if I put my hand like this, you go 0, 30, 45, 60, 90. Okay, that's how you label your fingers. 0, 30, 45, 60, 90. Okay, now what you do if you're doing sine, it's the numbers below. Okay, so if I wanted sine of 45, I do 0, 30, 45. So it'd be square root 2 over 2. Okay, would be sine 45. Okay. I am just going to check out the calculator, double check. I don't want to tell you so anything is wrong. It is, yeah. Now, basically, cos 45 is the fingers above. So it would be, again, root 2 over 2. Okay, it's always over 2. Now, the tan graph is fingers below, square root fingers below, over square root fingers above. So, 1 over root 3. Now, to work that out, 1 second, what have I? So, I'm going to have 0, 30, so that would be square root 1, which is 1 over square root 3. Okay, so 0, 30, square root 1. I turn it round is an easier way to do it, because then you've got sine over cos. Sorry, not sine over cos. Ignore me. You've got, yeah, well, it is sine over cos. It's your sine values over your cos values, which is tan anyway. Yeah, square root 1 over square root 3. Okay, square root 1 is 1, square root 3 is square root 3. Okay, so that was 0, 30. Okay, so we're looking for y to be 30. Now we've also got, if y is 30 here, that goes up, that gives us here 1 over root 3. Now if we go along here, it would hit there, which is going to be the same distance from 180, so that would be 180, add 30, which is 210. So that should be our answer. Now that hand trick is really useful. It's a useful way to remember it. I still remember it. I don't use it really at all because I don't teach further maths where I work at the moment. I have taught it before, but I don't at the moment. But it's a really good way of remembering it. So I'll do it one more time, just to explain to you if you're not sure or don't know. You got your hand 0, 30, 45, 60, 90. Now sine is square root fingers below over 2. So let's say I wanted 60. 0, 30, 45, 60, put that finger down. So it's root 3 over 2. Okay, sine 60. Okay, cos 60 would be square root 1, fingers above my thumb, square root 1 over 2, 1 over 2. Okay, tan is fingers below over fingers above. Okay, square root fingers below over square root fingers above, sorry. So, 30 and 210. Can you do a question on graphs, like find the linear solution? I'll have a look at the end of this paper, Caden, if that is okay, because I want to make sure I've done one paper one for everybody and gone through lots of different types of questions that can come up, but then I can have a look for a question like that. Yeah. Right. So, moving on to the next question. Just checking actually for this. Yeah, that's fine. I was just checking the working out because there's some interesting stuff on the mark scheme here I was just looking at. It said 30 degrees with no working would be 2 method marks. 30 degrees and 210 with no working will get you 4 marks. Correct answer could come from incorrect working, then you get no marks, basically. Right, next question. Okay, so 2x minus 3 over x minus 1 over 3x plus 1 as a single fraction. We need the same denominator, so let's make them all 3x. Okay, and then 1 is 3x over 3x. Right, we can now expand that, so we get 6x minus 9 minus 1 plus 3x all over 3x. 6x plus 3x is 9x. Minus 9 minus 1 is minus 10 over 3x. Now let me just make sure I've done that right, because I was hoping that would simplify, but maybe it won't. Okay, 3 times minus 3 is minus 9. Minus 9 minus 1 is minus 10. So, yeah, that's it. 9x minus 10 over 3x. I don't think there is a simpler way of writing that. Okay, moving on to the next question. That was a quick one. Solve this. X is positive. That's important because when we multiply by x, that means this sign doesn't change. If x was negative or you're not sure, then don't multiply because your sign flips if what you're multiplying by is negative or dividing by a negative. So 8 plus 3x squared is less than or equal to 10. Take away the 10, 3x squared. We've got plus 8 minus 10 is minus 2 is less than or equal to 0. Okay, right. Now, what I want to do here is, well, think about my solutions here, but also think about my graph, because I want to solve this as if this... I've missed something. That's 10x. I was thinking that's not particularly nice. Let's go back to the drawing board. So minus 10x plus 8 is less than or equal to 0. So it's timesing everything here by x. I put a double bracket there. Okay, times x gets 8. 3x times x is 3x squared. 10 times x is 10x. Minus the 10x, we've got this. Yeah, okay. Now at this point, I need to know basically the roots. What I want, if I do a quick sketch, is I've got some quadratic. I don't know where the roots are. Okay, I want less than or equal to 0. So I need these points, the roots, and then I need this bit under the x-axis because it's less than or equal to 0. So here I think I'm going to have to complete the square. So let's do that at the side over here. 3 times 8 is 24. We need factors of 24 that add to make negative 10. So I'm going to go with minus 8 minus 3 won't work. 6 and 4, minus 4 and minus 6 will work. Okay, so 3x squared minus 4x minus 6x plus 8 is less than or equal to 0. So we get, factorise the first two terms now. So x and then 3x minus 4. Factorise the last two terms here. We want the same bracket, so I think I'm going to take out minus 2. And then I get 3x minus 4 again is less than or equal to 0. Then I'm going to take this bracket out the front. So 3x minus 4. Put the x and the minus 2 together into a bracket. X minus 2 is less than or equal to 0. So our roots are 4, so positive 4 divided by 3 and positive 2. Okay, so actually, my y-axis should probably be somewhere over here, maybe. Although that is quite stretched now. It's not quite right, but yeah, you get the point. So this is 4 over 3, 1 1/3. This is 2. So for our answer, we want x to be less than 2, or less than or equal to, because we've got the equal to in the question, and then greater than or equal to 4 over 3. Okay, so nice question, a little bit trickier, similar to GCSE, but like I say, a little bit tricky. You've got to multiply by the x, and then you've got to complete the square without a calculator, which is a little bit trickier. So yeah, just be aware of that, and just obviously make sure you know how to do those things. This one, nice question, to do with powers, and got x's in there. So it looks trickier, but just applying basically what you should be able to do already. So x to the power of a half minus x to the 3 over 2 times by the same thing, x to the power of a half minus x to the 3 over 2 equals x squared plus x. So when we multiply, remember you add your powers. So if I do the claw method, I'm doing this one times this, and this times this, this times this, this times this. X to the half times x to the half is x to the power of 1. A half add a half is 1. A half add 3 over 2 is 4 over 2, which is 2. So we get add x squared. Now minus 3 of x to the 3 over 2 times by x to the half. You still add your powers together. We're just going to get a negative answer because you've got a negative times a positive. So 3 over 2 add a half is 4 over 2, which is 2 again. So minus x squared. Then we get minus x to the 3 over 2 times minus x to the 3 over 2, which is positive x. 3 over 2 add 3 over 2 is 6 over 2. Now 6 over 2 is 3. So that's equal to x squared plus x. X squareds cancel on the left hand side. We get x cubed plus x is equal to x squared plus x. The x's cancel. So x cubed is equal to x squared. So if I subtract that from both sides, because what we don't want to be doing here is just dividing by x squared, because we lose solutions if we do that. X cubed minus x squared is equal to 0. Factorise out the x squared, we get x squared, and then x minus 1 is equal to 0. So our solutions are x is equal, you think I missed a negative? I will have a look, I might have done, possible. That times that is positive, that times that might be negative. You may be right. Let's have a look. So x to the half, so that times that will be negative. A half add 3 over 2 is 4 over 2. Yeah, you're quite right. Thank you for letting me know. Let's go back through all of this then. Let's get rid of this second because things won't cancel. So thank you for letting me know about that. Now that, the first bit, is x to the power of 1. That's fine. Right, so we can get rid of these x's on both sides. We can do that. We've got minus 2x squared plus x cubed equals x squared. Take away x squared from both sides. We get x cubed minus 3x squared equals 0. Factorise the x squared out again. X minus 3 equals 0. So we get x equals 0 or x equals 3. If I haven't missed any negatives again, should be the right solution. Okay, let me just double check I haven't missed anything else out there. No, right, thank you for that, good spot as well. Yeah, focusing too much on the powers and not the negatives, until I got to the bit after that. Right, next question. You know, that's not too badly going anyway. I feel like I've done paper after paper after paper recently, and I think that's the first mistake I've made. Can you do a question on circle theorems? I haven't learned and it's hindering a chance to get a 9. There is a circle theorems question coming up. Hello, Phillips, whoever that is. Don't worry, you can go back through the stream and watch it later if you want to. Might be helpful, or just kind of pick up or, go to the questions that you think are most useful. Right, expansions of 1 plus 12x all to the power of 4 and a plus 4x all to the power of 3 have the same coefficient of x squared. Work out the value of a. So, power of 4, power of 3. Let's start by doing Pascal's triangle. So 1, 1, 1, 1 add 1 is 2, 1 at the side, 1 add 1 add 2 is 3, 2 add 1 is 3, and 1. So this is like the 0th row. Okay, if you have anything to the power of 0, it gives you 1. This is the first row, second row, third row, and then we do need the fourth row. Okay, so 1 add 3 is 4, 3 add 3 is 6, 3 add 1 is 4, and then we get 1 there. Okay, yeah, I can have a look at a circle theorems question on first class maths. I'll try and find it. I don't know if it's the exact same one, but, well, I don't know if I'll be able to find the exact same one you're talking about, but I'll try. Or maybe you're just talking about like a general like pack of questions of circle theorems. I don't know. I don't really use first class maths, but I'll have a look. Right. So, what we need to do, and I write these usually in columns, is we're going to do 1 to the power of 4 times... no, same coefficient of x squared. I don't even need to do all of them. So to get x squared from this first bracket, I need 12x squared. And then I will have 1 squared, because these powers add up to make 4. And then from here, I will have the fourth row, choose 2, which is 0, 1, 2, which should be 6. Okay, so that would give me the coefficient for the first one. Okay, and then for the second one, I still can't get my head around them. I've spent at least 10 hours trying to learn them and can't understand it. Same with proofs. Okay, for circle theorems, make sure you've got them on flashcards. Make sure you've learnt them. That's the first thing. You need to know them before you can apply them, because you need to see a question and then recognise certain shapes, and then obviously you know those shapes from learning the theorems, and then obviously once you've learnt them, you also know the reasons you need to put down. Right, going back to this one, 6 times 1 times by 12 squared, so that's basically 6 times 144 x squared, which I'll do in a second. Yeah, exactly, love. I agree. I'll do that bit in a second. I'll work that out. The next bit we have got, well, we need 4x squared to get the coefficient of x squared. So that would be times by a to the power of 1. And then we're timesing that, just box that off a little bit, by, this would either be 3 choose 1 or 3 choose 2. It doesn't matter, because they'll be symmetrical. So third row here, choose 1, 0, 1. You can see here 1 and 2 are the same, 3. Okay? 0, 1, 2, 3, 4. Yeah, that's fine, that is right. You question yourself, especially when you're doing this for everybody else to watch and you're a teacher. You obviously don't want to get anything wrong. Right, next one. 4 squared is 16. So we've got 3 times 16, which is 48. 48a x squared. Okay. Do you know what? I don't actually need to work that out at the moment. Right, so the coefficients must be the same. 6 times 144 has to be equal to 48a. Basically, I might need to do 6 times 144 and then divide by 48. I don't know if I could be particularly bothered to do that. I want to see if there's a quicker way to do it. Maybe there isn't. Right. I mean, the only thing I'm thinking here in terms of maybe making it quicker is writing things as a product of prime factors and then cancelling things out. Right, okay, yeah, I'm just trying to look at the comments. Okay. But I don't know what IWK means. I feel like I should know, but I can't remember. Binomial expansion, trig identities. Okay. We'll see if there's a trig identities question on this, but again, that's probably something that's more likely to come up in paper 1. Right, let's do this anyway. I'm wasting my time. 6 times 1, let's just do it manually. 144 times 6. 4 times 6 is 24. 4 times 6 is 24. Add the 2. 6 times 1 is 6, add the 2 is 8. So we get 864 equals 48a, divided by 48. So 864 divided by 48. Doesn't go into 8, carry the 8. 48 into 86 goes once. What's the remainder on that? 8, add 8 is 56. 38. Then we get 384. Ugh, it's not nice. Right. Scroll it down a little bit. Let me do some 48. 96. Add an 8 is 104. So 144. 104, yeah. Add a 48 is 100 and, well, add 40, 184, add the 8's 192. This is a pain. What a pain this is. Right. 192, add 48, add the 8's 200, so that's 240, which makes sense because that's 5 times 48. Probably could have just jumped to that straight away, would have been easier. And then we've got 288, we're nearly there. Right, basically I know it's going to be 2 more because I'm adding on 96, which is 248. So I'm just going to finish it off. I'm going to add on another 48, which is going to be, add on the 8 is 296, add on the 40 is 236, add on the 8 is 244, sorry, 384 is what we get. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so A is equal to 8. What a pain. Just do 192 squared, yeah. 18, yeah, sorry, I forgot the 1. 18. Right. Yeah, there we go. So, yeah, probably a quicker way of doing that, but ultimately it doesn't matter too much as long as you get the answer at the end. Right, moving on to the next one. Here, y equals ax cubed plus bx squared plus 7. Well, yeah, I think binomial does take a little bit of time, but it's not. It's more normally just like the Pascal's triangle bit, and that question took more because I was doing all that timesing and dividing stuff. So yeah, just a bit of a pain to be honest. Yeah, on your calculator, n choose r is a lot quicker. All right, that's interesting. Yeah, I hadn't considered that. 192 is the 4th, so 384 will be the 8th one. Right, okay, yeah. Quicker way of doing it. Good, cool, yeah. Right, next one. Has a stationary point, and that means when we differentiate it, the gradient's going to be 0. So it'll be equal to 0. So dy over dx equals 3ax squared plus 2bx, 2bx or not to bx. Plus 7 disappears because that's a constant, and so we know this is equal to 0. So 3ax squared plus 2bx is equal to 0. Now, I've got 2 letters here, which is a problem. I need to get another equation. 2 variables, sorry, not 2 variables, 2 constants, 2 letters, you need 2 equations. The other thing to do is plug that into this. So we get 11 equals a times minus 2 cubed plus b lots of minus 2 squared plus 7. So 11 equals yeah, those types of things, study grade 1, sound like the things that are likely to come up and the things that you need to make sure you know how to do, because if they're going to come up, they're going to come up on paper 1. Especially like trig identities, matrices, I would think. And the other things you've listed there are likely to come up but could come up on the other paper. But yeah, like those types of things, I would agree with you. Right, minus 2 cubed is minus 8a plus 4b plus 7. So, right. Now the other thing actually I need to do here, if it has a stationary point at this point, I plug minus 2 in. I'm going to do that in a second. Let's go back down here. Take away the 7. We get 4 is equal to minus 8a plus 4b. Now that is the first equation we're going to use. Okay, and then this one we're going to put in minus 2 because that's when it is 0. So 3a times minus 2 squared plus 2b lots of minus 2 is equal to 0. So we get minus 2 squared is 4. 4 times 3 is 12a. Minus 2 times 2 is minus 4b is equal to 0. And we could actually divide all of that by 4 before I write it down. That will give me 3a minus b is equal to 0. So 3a minus b is equal to 0. That isn't really any helpful because I'm going to have to multiply it again with the plus 4b. So I might as well just write it down as it is. So 12a here minus 4b equals 0. I'm going to add those equations together. Just imagine the zeros on the left hand side. So we get 0 add 4 is 4 equals 12a minus 8a is 4a, 4b add minus 4b is 0. So a is equal to 1. And then plug that into any equation. So if we plug it into this one, we get 12 lots of 1 minus 4b is equal to 0. So 12 minus 4b is 0. So 12 is equal to 4b. So b is equal to 3. Should be, unless I've made a mistake. The answer, yeah, you're right. I could have divided that other one by 4 as well. That would have simplified it. Yeah. So I could have done that as well. Gotta be honest, I didn't see it in time. So, yeah. And also, I'm conscious that there are some very good people on the stream. You know, if you're doing further maths, you are going to be quite good at maths. So, you know, you're going to be seeing these things as well as I am, to be honest. So, yeah. But I think, you know, if you're someone that's doing further maths, you're doing the AQA paper, there's lots of stuff on this which is really, well, not new, like extensions of GCSE stuff, which I think is really helpful. Because just applying that to like a slightly higher level. There are a few new things like matrices, maybe differentiation if you do the national GCSE, exact trig values, like some other little things. But like there are a lot of things which are slight extensions, which is nice. I've revised the night before, just cover them now. Yeah. You're not cooked, Mark. You're not cooked. Be positive. You know more than you think you do, and there's only a few things, and you know hopefully this stream will help. But have a look through the past papers tonight. Have work through some of them. They're only an hour and a half. I say only an hour and a half. It is time, but you've got time tonight. You'll have some time tomorrow morning maybe that you can do some revision, learn some things. There is time. You know more than you think. I'm sure you do. Anyway, you know, stay positive, manifest it. That's what I say to my students, manifest it. Right. Okay, how do we do this? Now, we need to eliminate one of the variables first and then eliminate another one. Let's call that equation 1, call that equation 2, that equation 3. Let's multiply equation 1 by 2. Okay, so equation 1 times 2 gives us 4x plus 2y equals 26. Let's call that equation 4. We've got 2y here, we've got minus 2y here, so let's do equation 4 and equation 3. Okay, so we get 4x add z. Okay, minus 2y add 2y cancels. 26 add minus 7 is 19. And then what we can do, let's call that equation 5. We are going to do, we're going to need to do equation 2 times by probably 4. So equation 2 times by 4, we get 4x again, plus 12z equals 8. That's equation 6. And then we're going to do equation 6, take away equation 5. So 4x take 4x cancels, 12z take away z is 11z. And then we've got 8 take away 19 is minus 11. So z is minus 1. Nearly done on this paper, and actually quite quickly. I feel like it's quicker to do these papers, these further maths AQA papers. Um, Differential curves. It is about mentality. I agree with that. It's definitely got a big element to it. Um, but I think particularly more so because, like I said earlier, a lot of people doing further maths are good mathematicians. You wouldn't be doing further maths if you weren't. You're going to be able to take on things quicker, um, quicker than probably you expect. So, yeah, practice, and you're better, like I say, than you think you are. Got some clashes. If we could just mind our language in the chat, that would be appreciated. Fit the entire spec on a post-it note. Yeah, well, to be honest, if you just put the new things on there that are like exclusive to further maths from normal maths, then yeah, probably. You need to get above 68 for a grade 9. Okay, right. I don't know. I can't confirm that myself. I haven't looked at the grades, but okay. Doesn't sound too bad if that's true. Types of questions they can ask for each of it on the specs loads. I reckon it'll go up 73 marks from 9, possibly. Yeah, right. Okay. Right. Back to this. Z is -1. Right, so we need to put that in now to one of the equations with just z in. So let's go with number 5. So substitute z equals -1 into 5. Also, I think it's quicker to do these questions than, like I said, national GCSE or the IGCSE. So I think actually you're going to have more time on the paper probably to work things out. So it's just a case of knowing it and not so much about the difficulty, I would suggest. X is 5. We're going to plug that now into any equation. Let's go with number 1 to get y. Right. 69 for a 9 last year. Okay. I presume that's percent. Predicted paper, no. I haven't made a predicted paper. There might be some online, but typically I would just do the past papers. Just do paper 1s. They are predicted papers, essentially. That's what they're good for. That's what I would do. I found one. If you found one, share it in the chat. Yeah. Yeah, maybe check out First Class Maths. They're normally quite good for them. Although I don't know if they do the further maths papers. IGCSE is International GCSE. I work at a private school and we do the IGCSE. I have worked at a state school before, so you know, don't hate me in the chat for working at a private school or not working at a private school or whatever. Right, sub x equals 5 into number 1. So 2 times 5 plus y equals 13. So 2 times 5 plus y equals 13. 2 times 5 is 10 plus y equals 13. So y should be 3. So y is 3, x is 5, and z is -1. Okay, just double check that on the mark scheme. Yeah, that's fine. Right, moving on. I mean, like I say, it's 6. I started at 5 o'clock. I've done a lot of talking, and I've nearly finished the paper in an hour. So there's a lot more time on these papers. What methods can I do if I've done the same papers about 8 times? Have you done all the papers? Right, if you've done all the papers, what I would do is try and work out which topics you struggle with the most. Have a look at those. I don't know, I'd have to check whether there's things on Maths Genie. Bennett Maths, yeah. You know, check out some places like that. But I typically use Maths Genie. The other thing, I mean, if you've done all the papers, you're in a very good position. Yeah, check out maybe some websites online. Find some websites with further maths stuff on it, or topics. If you've got any textbooks, I mean, the school I work at, we use textbooks. Using those. Other than that, I'd have to have a think. I'd have to have a look online, to be honest. But I can do that after I finish this paper. Just a couple more questions to go. Right, this one, completing the square. So, I'm going to complete the square on the first bit. I need to take out the factor of 8 though, which is a bit annoying because 20 divided by 8 is, or 20 over 8 simplifies to 10 over 4, divide by 2, 5 over 2. Okay, 5 over 2x plus n, which is not great. I'm going to actually change these to square brackets as well, just to separate it out a little more visually. 2.5 times 8, yeah, that's 20. Right, next bit, 8, and then complete the square here. So x plus 5 over 4, you half the 5 over 2, squared, minus this squared, so minus 25 over 16 plus n. Multiply the 8 back in, so we get 8 and then x plus 5 over 4 squared minus, now the 8 on top will mean that I can basically cancel the 8 and the bottom becomes 2 because 8 over 16 is a half, so I get minus 25 over 2 plus n. Okay, so that's got to be equal to 3, so that's how we can work out the n. The c is 8, the d is 5 over 4, I already said n over 4, and then 3 is equal to n minus 25 over 2. Add 25 over 2 to both sides. 3 is 6 over 2. 6 add 25 over 2 is 31 over 2. Should be n. Okay. Now, obviously, what we could do is we could put those numbers back in and just expand it if we wanted to. But yeah, probably won't need to be honest. Those are reasonably nice fractions, so reasonably confident. But again, you know, you've got time. You might want to go back in and check that. And I'll totally understand if you did want to do that. Yeah, that's fine. So 504, 8, and 31 over 2. Okay. Right, next one. This is a circle theorems question. I know some people in the chat were asking about circle theorems. Revise the bio exam. Should I do that? AS level maths papers, but only the further content. Yeah, you could try that. You could try that. Definitely, there's some stuff that overlaps. Don't have circle theorems. What do they have? They have some stuff on circles, although the circles on this further maths paper is going to be a lot easier. But to stretch yourself, you could have a look at some circle stuff on Maths Junior's got AS maths on that. What other topics kind of overlap? Differentiation. Okay, so you can have a look at some of those. But yeah, quite a lot of the stuff on the GCSE AQA further maths isn't on the A level or AS maths. So yeah, just be aware of that. Might not be the best. Differentiation, yeah. The other place, I don't know if they do this, but there's another, yeah, stationary points and differentiation, good. There's another YouTube channel which is really, really good called TL Maths. If you haven't heard of it, really, really good for A level. So I presume a lot of the people probably listening to this will be going on to do A level maths. So yeah, TL Maths, really, really good. Got videos for everything. He might have IGCSE content, so maybe check that out. Point of doing further maths A level. Good question before I do this circle theorems question. When you do your degree, when I did my degree, a lot of the further maths A level content overlapped with my first year degree stuff. And I presume a reason why that's the case is because what they want is for everyone to be up to the same level before you do your second year and your third year stuff, which typically your first year doesn't count in terms of your grading for your degree. So yeah, it makes your first year a lot easier, a lot more relaxed. You've got time for a lot more hanging out with people, meeting people, having fun, because you don't have to stress as much probably about your maths. But having said that, it's your first year, it doesn't count, and a lot of people didn't really seem that stressed in my first year. But anyway, right, I'll do this question now. So P, Q, and R points on a circle. Work out the radius of the circle. So we want to work out this bit here. Okay, right. I know this is going to be 60 because the angle on the circumference is half the angle at the centre. We've got this arrowhead here. Now, from that, what I can do is I can use the 60, the 4 and the 5 to work out PR, and then I can do like inverse cosine rule to work out one of the sides, basically. So I think that's what I'm going to do. Not easy, but we're going to try it. So cosine rule here, or you could use sine rule. Yeah, we could use sine rule with the x and the 120 and PR. Yeah, let's use cosine rule first of all. So you need to know this, so because there's no formula sheet. Okay, so a squared equals b squared plus c squared minus 2bc cos a. So, b squared, we're looking at PR. So PR squared equals 4 squared plus 5 squared minus 2 times 4 times 5 times cos 60. Okay, so you need exact trig values for this question as well. So PR squared is 16 plus 25. 2 times 4 is 8 times 5 is 40 minus 40 cos 60. Well, if you do get a formula sheet, I need to check that it's not on the paper like with the other stuff. So I can have a quick look now. Let me have a quick check rather than having people that aren't sure of anything. So AQA further maths formula sheet booklet. Let's have a look at this. That's A level. That's not what I want. GCSE. That's the GCSE one, not the further maths one. Let me have a look. Yeah, this looks like it. Yeah, yeah. Right, so you have got a formula sheet. It does have cosine rule on it. Forgive me. You're right. It does it. The other things that are on it, you probably already know this. Trapezium, area, volume of prism, circumference and area of a circle. Why you need that on the further maths. GCSE is beyond me. Got your quadratic formula, Pythagoras, sine cos tan, sine rule, cosine rule, half AB sine C, tan theta is sine theta over cos theta, sine squared plus cos squared is 1, equation of a straight line, y minus y1 equals m brackets x minus x1, and the general equation of a circle, x minus a all squared plus y minus b all squared equals r squared. Apologies for that. The reason I thought that, to be honest, is because when you get to A level, you don't have any of like cosine rule or sine rule. You have to know them. You've ruined the fun for me, study grade 1. I was going to work out what cos 60 is. I'm going to test myself on my hands to make sure I know. 0, 30, 45, 60. Square root fingers above square root 1. Okay, because it's 0, 30, 45, 60. Cos is above. Square root 1 is 1 over 2, which is 1 over 2. You do definitely get a formula sheet, you're right. Yeah, you do definitely get a formula sheet. Apologies for the confusion. So that's 21. PR squared. So PR equals square root of 21. Okay. Right, then, I know these are both radii, so I can work out these angles and just do the sine rule, which would probably be easier. 180 take away 120, 60, so this is 30. So I know if I want x, I want x over sine 30 is equal to root 21 over sine 120. What would I do if I woke up as KSI? Great question. I'd rejoin the Sidemen. That's what I would do. I'm not going to say any more about that because, yeah, but that's what I'd do, definitely. Yeah, yeah. Bit of drama going on there at the moment. You got square root 7 already? You're ahead of me. I'm too much chatting. Right, sine 130, let's work that out. So 0, 0, 30. So square root fingers below is 1. So 1 over 2 is a half again. So we've got x over a half equals root 21. Now sine 120, if you think about your sine curve, it goes like this. This is 180. This is 90 here. So 120 is going to be the same as 60 because that difference has to be the same. So 120 is here. That is 60 down from 180 to 120. So that is going to be the same as sine 60. Okay. So that's the same as sine 60. So 0, 30, 45, 60. So that is root 3 over 2. Okay, so I've got x over a half equals root 21 over root 3 over 2. Well, I wouldn't eat raw meat because it can make you ill, I think. So I would rather be a vegan than eat raw meat. Or physically be like raw meat, still a vegan. Because I don't want to be a piece of uncooked like chicken. I'd rather be a vegan. Right. I could cross multiply, can't really be bothered. Let's, on the right hand side here, times top and bottom of the main fraction by 2. So we get 2 root 21 over root 3. Okay, and then we're going to do x is a half times by 2 root 21 over root 3. The half and the 2 cancel, so we get x is root 21 divided by root 3, which is root 7, which is what someone said in the comments. So, yeah. Yeah, that ADW1Z in the chat. Yeah, very good advice there. You can learn them. I actually don't, I haven't learned them. I don't learn that I draw the graphs because that means I don't have to, well, less to remember. I just remember the graphs and then look at the symmetry and stuff. But yeah. Right, I'm glad that's helpful, Philip. I'm not sure whether you mean the maths or my opinion on whether I'd be a vegan or a raw piece of meat, but regardless, I appreciate it. Right, that's the end of that paper. So if there's stuff that people want me to go through, I can, but it's very quick. You said, I've been waffling, as someone said in the comments last time, and I finished 8 minutes early. The finger thing you do for trig values, good question, I'll explain it again. So basically, got your hand here, 0, 30, 45, 60, 90. Okay, so if I want to do, like, let's say sine 40, let's do sine 60. 0, 30, 45, 60. Put that finger down. Now, sine is square root fingers below, so square root 3 over 2. Cos 60 is square root fingers above, so square root 1 is 1 over 2, a half. If you do tan 60, square root fingers below over square root fingers above. So that would be root 3 over root 1, which is root 3. Okay? And you can do that for anything, 0, 30, 45, 60, 90. Okay? But to be honest, 0 and 90 you should know from the graphs anyway. So just the rest. Can you make a tier list of your lower 6 sets? No, I can't do that. A few reasons why. Wouldn't be right to do that. To put people in a tier list, not right, not a kind thing to do. Also, I can't give out any details of anybody that I work with or anything like that. So yeah, can't do that. You probably knew the answer to that question though anyway. Circle theorem's proof. Yeah, let's have a look at something like that because there was, that's something that can come up. So let me just find a paper with that on. I don't know if that's on paper 1 or paper 2 typically. I think it can be on either. Let's have a quick look at, I'm going to have a quick look at some paper 1s. That's a 2024. I have also, people have done a live stream in the past of 2024, so check that out. That'll be on my lives on my channel. So if you're interested in more like practice, have a look at that. I'm just seeing if I can find. They are very similar, aren't they? Is this a proof one? No, that's one working out an angle, circle theorems. I'm gonna show you this question because someone did ask about something like this in the chat. The game is not gone. The game is not gone. The games are starting Thursday night. World Cup. I'm looking forward to it. I don't know if anybody else is, but I'm really looking forward to it. Right, let's do this. Let's full screen this so you can't see the side bit. Now the actual question for this is. Yeah, right. I've done my fantasy team as well for the World Cup. But on the app, there is you can do a fantasy team, which is really cool. So if you're looking for some downtime in between your exams, that was a bit of fun trying to make that. I'm probably going to change it before the the stream, but not the stream, before it starts. Yeah, I need this question right. Let's have a look. So let me make this graph a little bit smaller so I can try and get everything on one page or one, like, so you can see it all. So by drawing a suitable straight line, work out approximate solutions to this. Now what we want to do is we want to make it so that we've got y, basically we want to split this up so that we've got this and something else on the other side, okay? So firstly I notice I want minus x squared. Let me write it on the side here so it's easy to see. X squared minus 7 over 2x minus 3 equals 0. I want minus x squared, so let's put that on the other side. Minus 7 over 2x minus 3 equals minus x squared. What else do I need? I need plus 3x on the other side. So at the moment I've got minus 3.5x. So I want to split that up into minus a half x, minus 3x, and then I'll leave the minus 3 and sort that in a second. So now, minus a half, minus 3, let me just check that is working the right way that I want it to. So minus 3 over 2 is 6 over 2, yeah, that's right. So, because we want positive 3x, so when we put that on the other side, that'll be positive. So we've got this, minus x squared plus 3x. And then what we need is we need 6 on the other side. Do you know what? An easy way of doing this, or another way of doing this, is just add 6 to both sides. Just add 6. So we get minus a half x. 6 add minus 3 is plus 3. Okay, and then we get minus x squared plus 3x add 6. Okay, which is this is what we want. This is this up here. Okay, that's what you want. Now, what I'm going to do here now is I'm going to just write this again, but I'm going to do something else. So I'm going to write minus a half x plus 3 equals y equals minus x squared plus 3x plus 6. And I'll put y in the middle, but they're both equal to y. So actually, that's why I could get rid of it or didn't need it in the line above. Now, if they're both equal to y, I need to plot this. And where that is equal to this on my grid is going to be the solutions. Okay, so I'm plotting y equals minus a half x plus 3. It's going to go through at 3 and minus a half x. So every 1 unit it's going to go down by a half. So if I go along 2, it's going to go down by 1. Okay, down from 3 to 2. And I could check that, so I could put that in. Minus 2 times minus a half is 1. Add 3. I'm going the wrong way. Because it's minus a half, I go left, it should go up 1. There we go. Okay, good job I checked it. And what I would probably do, to be honest, is either, well, you can't use a table function, it's on paper 1. Just use your endpoints. We need to go from 5 and minus 2. Minus a half times 5 is minus 2.5, add 3 should be minus a half. That's 1. Minus a half is going to be like, if that's 1, it's going to be half of there, which is going to be somewhere like here, I think. Let's put 4 in, that will give us a nicer number. 4 times minus a half is minus 2, add 3 is 1. Okay, so we do this, do our straight line. I'm going to go through that one there. Should be 1.125, yeah. Which is why you do the whole number ones, because I've done my last point in the wrong place. Half of 2.5 squared is 1.125. Right, shout out. Actually, no, I'm not going to do. I'm not going to start doing shout outs. I'll have a look at that question. Thank you for sharing that question, Study Grade 1. I'll have a look at that one in a second. I'm just reading what you put in the chat about another way to do that. Okay, that's an interesting way of doing it. ADW1Z. I haven't ever seen that before. But yeah, that's interesting. This is equivalent to my approach would be set that equals ax plus b. Okay. So you've got 3x, okay, and then you've written it as 3 minus a, and 6 minus b equals 0. Want to solve. Okay, so you've just put it all on the other side and made it negative. Okay, yeah, so it's kind of like a way of equating coefficients, but yeah, that's quite cool. Makes sense. Right, back to this, just finishing off. My solutions here would be here. So that is about, that's going to be 0 0.2, 0 0.4, 0 0.6. I'm going to go minus 0 0.7. Doesn't help that I've done all of that, like, crossing on it. Yeah, I'm going to go minus 0 0.7 here. And then this one, I think that is 4.2. Yeah. Okay. So yeah, that's how I would do it. But like I've shown you one way. Somebody else has said it in the chat. So yeah. Right. Moving on. There was a question someone put in the chat. Paper 1, 2022. I'll have a quick look at that one. I have got a bit of time. I've been told that dinner's not ready till 7 o'clock, so I've got a bit of time. Right, paper 1. It's boiling in this room. Paper 1, 2022. Question 15. So a quick look. Scroll down, scroll down, scroll down. Okay, yeah. Perfect. How you plotted the points? Okay, I'll just go back. So I plotted these points by basically substituting different x values into this. Okay, so you can just do the end points, it's probably easier. So minus 2 into here, minus a half times minus 2 is 2. 2, wait a second, let me do that again. I was confusing myself then. I got 2 and it wasn't 2 and I was, yeah. Minus a half times by minus 2 is 1. Your half the 2 is 1. 2 negatives make a positive. 1 add 3 is 4. Okay. 5 times minus a half is minus 2.5. Add 3 is about 1.5. Am I doing that right? I'm getting myself confused now. But that's how you do it. You substitute the values in. Minus a half times 4 is minus 2, and 3 is 1. Okay. The other thing I would say about that is I would definitely do a third point. I wouldn't just do the end points, because you can quite easily make a mistake. Like you could quite easily forget a negative, or like I nearly did then, like not half something when you should have half something. So yeah, I would definitely do 3 at least, just to be sure. But yeah, right, let me get this question. I've just got it. I just need to copy it over. So print screen this. I've seen this one before, but to be honest, I've probably seen most of these questions before. Right, let's put this on here. So, here, right. Prove that y equals 90 plus x over 2. Do you know what? I quite like these questions. I don't know why, but I do quite like them. Just because they involve using your circle theorems, I think they're quite nice. I like all circle theorems problems, to be honest. They're very problem-solving if that's a thing. Right, so first thing I would do here is I would work out, well, this one has to be 2y. Okay, the angle at the centre is twice the angle at the circumference. That then makes, well, I know that a radius meets a tangent at 90 degrees. I know that. I know this radius meets a tangent at 90 degrees. I know that these have to be the same length. Okay. What I don't know, which is what a lot of people fall for, is that this is the x is half of the y, and it can't be. Right, I'll answer that question in a second. Right, so, but you know what? I'm pretty much there already, because I've got a quadrilateral here. Now I've got these two 90s. This has to be 360. minus 2y. So I do 360 degrees in a quadrilateral, minus 90, I don't know why I did the 0 like that, minus 90, minus 360, minus 2y. Okay, and that's equal to x. So x is equal to 180 minus 360 minus, or plus 2y. I'll take out the bracket. So we get x is equal to 2y minus 180. We need to rearrange it now. So x plus 180 is equal to 2y. Divide everything by 2. Y is equal to x over 2 plus 90. Or we could write that the other way around, just to make it all the same as what we need. 90. Okay, so that's quite nice. And it wasn't as tricky as I thought it might have been. Yeah, do you know what? It's a weird thing at exams. Like, would I cancel them if I could? I don't know. I don't know if I would. I think it's more complex than that because, you know, I know it's very stressful now, but obviously there are reasons that exams were set up in the first place and stuff. And like when exams weren't a thing or were taken away during COVID, like that has different effects and means different things. So I don't think, yeah. Anyway, sorry to dig too deeply into that, but you just want to go, yeah, I'll cancel them all. That's what you want to hear because you're stressed about it tomorrow. Yeah. Right, I'll see if I can find another one of those, but that one was quite nice. Let me have a look. So that was done 24, 23, 21. There's not loads, is there? I felt like there was more than this, but clearly there's not. Let's have a look at 21, see if I can find anything. I think what I would find reassuring with this stuff is that there aren't too many different things they can do. And like looking through all the paper ones, they're all quite similar in terms of layout. Obviously the difficulty changes, but in terms of things they're asking you to do, they're quite similar. Having a quick look through. Is this a proof one? This looks like one. Right, let's have a look at this one. So you have a way to memorise all the matrix squares we need to know. To be honest with you, I don't. Flashcards is what I would use. Again, if I'm honest, I don't remember them all because when I last taught the further maths GCSE stuff, I didn't actually teach that bit of it. That was taught by another teacher. So yeah, I don't know them all off the top of my head, but I know you can learn them and there's not many to remember. There are probably ways you can work them out as well, which is what I tried to show earlier. Might be helpful. You know, I think if you can learn a method, that's one thing you've got to learn as opposed to like 4 things. So, okay, box graph. Yeah, I explained it earlier. Yeah, exactly like ADW1Z saying. Unit vectors 1, 0, 0, 1, and then mapping to different things. Yeah. Right, let's have a look at this one. F, H, K, and J are points on a circle. Chords H, J, and K, F intersect at L. E, F, G is a tangent to the circle. F, H, and J, K are parallel. That's important. Angle FHJ equals 2x. Give reasons why FKJ, so where's that? FKJ is 2x, and HJK is 2x. So this one, angles in the same segment are equal. And then we've got for that other one, because we've got parallel lines here, we've got alternate angles are equal. Right, work out the values of x and y. Okay, so, well, we've got here, we can make one equation from this one. And then we could probably do this another way as well. Let's have a quick think. We've got 3y here. We'll probably need to use that. So the bit I'm reading here is work out the values of x and y. So we know that 4x plus 7y equals 180. If nothing else, once you work out one of them, that's going to be quite helpful. Now, from there, we know that this has to be equal to 3y because we've got a triangle here and we've got this angle here. So alternate segment theorem, they have to be equal. So again, looking at this triangle, HFJ, we have got 2x plus 3y plus 98 is equal to 180. So 2x plus 3y is equal to 82. This is equation 1, this is equation 2. So I'm going to double equation 2. I'm going to get 4x plus 6y is equal to 164. That's equation 3. I'm then going to do equation 1, take away equation 3. That's going to give us 1y is equal to 16. Okay, so 180, yeah, that's right. And then we're going to substitute that in. Let's go with 2x plus 3y equals 82. So 2x plus 3 times 16 is equal to 82. That's 2. I'll try and box this off a little bit. 2x plus 48 is equal to 82. So 2x is equal to, add 4 is 52, 34. So that gives us x is equal to 17. Okay. Personal hardest question is a difficult one on the spot because there are lots of different ones. I'll show you a nice one I just found. But yeah, yeah, I'll show you a nice one I just found. I have done it before, but I can't remember it, like how to do it. Obviously, I can't, you know. There's lots of nice questions on there. Like this is it. I might find the answer to this one as well, just to make sure, because I could see myself, if I'm not careful, making a mistake or getting mixed up. So, because it's a nice question, but it's a different question. It's this one here. So I'll give you a chance to just read it a second, and I'll just make sure I've got the marks in, just so I can check. Haven't made any silly mistakes on this one. Actually, how many questions were there on this paper? There was 23 on that one. So that is paper 1 on 2021. Paper 1, 2021. That was in November for some reason. Interesting. Right. So, Mary's date of birth is 14th of 9th, 2006. She makes a 4-digit number code using the digits from her date of birth. 4-digit number code using the digits from her date of birth. So we've got 0, 1, wow, I've got 2 as well, rather than 4. 2, 0, 1, 2, 4, 6, 9. Must not start with a 0. Okay, must have all different digits. So for we've got four digits here. So the first one, we've got 5 options. 1, 2, 4, 6, 9. So that's 5 options. Have all different digits. How many codes can she make? Well, the next one, well, she can have 0, and then we're losing one of these. Okay, so 0 and then 1 less. So plus 1, 2, 3, 4, 5. So plus 4 in terms of the options. Here we've got, well, there's 5 there. We've got 4 options here because we've used one of them. We can't have the same digits. We've got 3 here. Okay, so in terms of total options, we've got 5 times 5 times 4 times 3, if I'm doing that right. So yeah, 300 is the right answer. Yeah. Personal hardest questions. Has anyone done paper 1 of 2025? Now, typically, well, that one's not released study grade 1, typically because that's like, they don't release the papers until a year after they've been out, so they won't release it until afterwards. You might have done it in school, but like I won't be able to show it on here. It's not available online because schools might want to use it for like mock exams and things like that. Question 17A and B. Right, is that on 2025? Yeah, right, okay. I won't be able to find that or use it. But let me have a quick double check. AQA, further maths, past papers, GCSE. Let me have a look on the actual AQA website just to be sure. But I'm sure that's normally the case. 6. Qualification, level 2 further maths, that's what I want. Exam series, no. They've got a sample set on the website, on the AQA website. You might not have seen that. I'll have a quick look at that now. They've got paper 1 and paper 2. So let's have a quick look at that. What I'm going to do, I'm going to print this onto here. And then you can have a look at it yourself because you might not have seen it. I know I don't think I've seen it before. So this is a sample, so why has it done it over there? Frustrating. Let me redo that, put that over there. Combinatorics, yeah, combinations. Let me print this in again. Has anyone seen the sample paper? So this is the sample paper. Oh, right, okay. Was it easier? Quite often they're a little bit trickier, sample papers. Right, I'll have a look at 2022 then in a second. I'll do that. Yeah, you've done the sample paper? Okay. Yeah, so, basic indices laws that start here. Um, Solving this one, you cube it and then solve. Multiply out your brackets, compare coefficients. This is a really interesting one, actually. This is one that I've seen people struggle with on a GCSE paper, and actually it's not that difficult. So A to B to B to C is in the ratio of 5 to 2. Now you need to break this down into vertical and horizontal numbers, and then use your ratio. So vertically, we're going from 7 to 5.5. So that's 1.5 minus 1.5. And then horizontally, we're going from 3 to 5, so that's plus 2. Okay. So what you want to do is divide that by 5 and times by 2. So minus 0.3, so minus 1.5 divided by 5 is minus 0.3, and then minus 0.3 times 2 is minus 0.6. So you're going to go down minus 0.6, and then 2 divided by 5 is 0.4. 0.4 times 2 is 0.8. So you're going to go right 0.8. Okay, so 5.5 take away 0.6 is 4.9. And then 5 add 0.8 is going to be 5.8. Yeah, good luck everybody. You did that very quick, study grade 1. Quicker than me anyway. If you're working that quickly, like the things you need to, obviously you need to know everything, but then ahead of that, what you need to be able to do is make sure you can check everything and know how to check stuff as much as you can anyway. Yeah, good luck, Mark, Zach, whichever one of those is your name, maybe both, I don't know. But yeah, good luck everybody. This one, just a tip, write this as 2x to the 10 minus 3x to the minus 2. Okay, so write it like in a linear format where you've got x and a power. If If you've got x squared on the bottom, bring the x up, power becomes negative. That should be simple. You're going to factorise and then simplify. Here, work out the area of the rhombus. Rhombus, parallel lines. So this 120, this 60, 120. You're going to split it in half. Okay. And you're going to use angle ABC is 60, so that would be 30, 120, 30. Now if it's a rhombus, same length. Okay, half AB sine C, work out 1/2 times by 2. Okay. 32 root 3. I hope you're all using calculators for this, or maybe you just know what sine 120 is. We did it earlier actually, so maybe you can just do it in your head a bit quicker. Let's have a quick look at this one. Got a curve, got maximum point and minimum point, intersects the y-axis. Sketch the curve. Right. So what you need to do for this is, on the axis sketch, label the points L, M and N. It crosses the axis at 3 distinct points. Doesn't say you need to label them. Now normally you would label them. However, I don't think they're going to expect you to be able to, or expect you to find the roots for this. Oh, you've got a different way to do it. Fair enough. Yeah, that's good. So here, like, is a positive cubic, so it's going to start bottom left, finish top right. Now the way I remember that, or one helpful way of remembering that, y equals x. Okay, not a straight line, but you know what I mean. Y equals x goes like that. Starts bottom left, finishes top right. The power of y equals x is odd. Any odd powers start bottom left, finish top right. Even powers, positive cubics go this way. Negative cubics start top left, finish bottom right. Okay, so like y equals minus x goes the other way. Okay. So just try and simplify things into examples that you know or understand is helpful. So here, maximum point at minus 113. So minus 113, somewhere up here. Crosses at plus 6. Okay, so we're going up, we're going down, and now the minimum point is at 2 minus 14. So it's going to go way down and then back up. So that's 6, that's L, which is minus 113. Okay, and that would be not a very good sketch. I know I would do this better normally, but you just need that. I don't think they can expect you here to do the roots. I think that is asking too much, and they don't say that in the question. I mean, I can just check the mark scheme very quickly, but I think that would be unreasonable, to be honest with you. What question was that? 8. I mean, yeah, they're not gonna expect you to do it. No, it just says crossing x-axis twice for x greater than 0. Crossing x-axis once for x less than 0. Yes, it's fine. Right. Okay, this one's quite nice. If AC is the diameter, then we'll have a right angle in this. But what we also know is that we've got a quadrilateral here, and these opposite angles in a cyclic quadrilateral add to 180 degrees. So 3x add 4x add 3x is 7x equals 180. So we get 10x is equal to 180. X is equal to 18. So that's 18 there. 4 lots of 18 is 72. 2 lots of 18 is 36. 3 lots of 18 is 54. Now if you add those together, for both you get 5x. 5 times x, 5 times 18 is 90. So this is a right angle, okay. As there's a right angle at D, AC must be a diameter of the circle because the angle in a semicircle is 90 degrees, okay, or words to that effect. Okay, next one, got some function stuff, which is quite nice, but with fractions. I'm not going to do all these questions, I don't have time, I do have to get off in 5 minutes, but yeah, just interesting to have a look at. Line y equals k intersects the circle at the points 1k and 5k. Circle centre C touches the y-axis at the point 0, 2. Okay, right. So we know that is at a height of 2. Okay, so we know the length. Actually, no, we don't know. So that is at 0, that is at 2. So this is at a height of 2. We know the radius has got to be more than 2. Quickly go through. Yes, I'll do that. I'll do that. I do like the look of this one though. This is interesting me about how we do this one. Wonder if I give that like an A plus B and then start working out. I might come back to this one anyway. X plus 3 squared plus y minus 2 squared equals 9? Quite possibly. Do you know what? I'll just check it for you, the mark scheme, just so I can tell you if it's right or not. What did you put? X minus 3 squared plus y minus 2 squared equals 9. Yeah, spot on. Let me do that question for you. Question 17, A and B 2022. I want to work that question out though, that I'll just put on the board in a second. Right. 2022, 2022, 2022, 2022, paper 1. So, oh, that's the modified papers, insert, modified papers, examiners reports. There's so much stuff on the AQA website, like trying to work your way through it all and find everything. Find what you want to find. Right, let me just put this on here. I am going to come back and do that question because I like the look of that. I just want to make sure I do this one first. Right. Go. Right, 17 A and B. Right. Okay. The point P lies on the circle x squared plus y squared equals 16. Okay, so this is length 4, and this is 4. So the yeah. Okay. Show that the coordinates of point P are 2 and 2 root 3. Right. So how many 60s go into 360? That's 6. So we're dividing it by 6. Do I work out the arc length? Would that help me? Possibly, possibly not. I can do that without doing it that way. I could do. What if I put a line up here? If I zoom this in, if I do a line like this, I can use trigonometry because I can work out that height in this base. So let's do that. So, this side here is going to be opposite and hypotenuse, so that's sine. So sine 60 is opposite over hypotenuse, so 4 sine 60. Okay, and then this bit here, I imagine, is going to be cos. So adjacent hypotenuse, so cos 60 is equal to adjacent over hypotenuse, so 4 cos 60. Okay. So then cos 60, 0, 30, 45, 60. So it's going to be square root 1 over 2. So it's a half. So we get a half times 4 is our x. And then we're going to get sine 60. 0, 30, 45, 60. So that's going to be square root 3 over 2 times by 4. So 4 times square root 3 over 2 equals 2 and then 2 root 3. So that's the first bit done. Nice question though. Nice question. Right, next bit part B. Work out the equation of the tangent to the circle at P. Okay, right, x plus ay equals b. So we want the tangent. Yeah, I do need to go. I'm running out of time. So tangent here. Right. So what we need to do is work out this gradient. So gradient of OP equals, let me try and do this quickly, 2 root 3 minus 0 over 2 take 0, which is equal to root 3. Okay, so perpendicular gradient is equal to minus 1 over root 3. This doesn't look very nice. It says A and B are constants, tells me it could be surds. Right, so we get y is equal to minus 1 over root 3 x plus c. We're going to substitute our points in now, so 2 and 2 root 3. So 2 root 3 equals minus 1 over root 3 times 2 plus something. So 2 root 3 equals minus 2 over root 3 plus c. So we get 2 root 3 plus 2 over root 3 equals c. Let's rationalise the denominator here. So 2 root 3 plus 2 root 3 over 3. So this would become 6 root 3 over 3 equals c. So we get 8 root 3 over 3 is c. So my final answer is, I'll just do it over here, y equals minus 1 over root 3 plus x plus 8 root 3 over 3. Did they want it in that format? No, they want it as x plus ay equals b. So they want x by itself. So times everything by minus, or times everything by root 3. Root 3y equals minus x plus root 3 times root 3 is 3. Cancels with the denominator, plus 8. So we get x plus root 3y. What do we do with that constant? Leave it on the other side. Equals 8. Okay. I'll just check the mark scheme, but that looks good. I don't know what question that was now. Let me have a look. 17. 17A, 17B. Yeah, that's fine. Okay. You're very welcome. You're very welcome. Right, let's go back to that other question. I want to get that. I want to work that out. Right. So line y equals 1 equals k. That lies on the circle. Let's write down x minus a squared plus y minus b squared is equal to r squared. So we can plug 0 and 2 into that. Let's see what we get. You're very welcome. You're very welcome. Good luck. Good luck. Diameter is 6. I'm trying to work out how we're getting diameter is 6. The other thing I'm thinking here is this radius here will bisect this chord. So the difference there is 1 to 5 is 4. Half of that is 2. That bit's 2. This is a radius. I don't know what that's going to be. Like, do I do intersecting chords theorem here? I could do that. Let me have a think. Would that work? Some people might not know what intersecting chords theorem is. So I could say this is r, this is x, this is r minus x. That's not going to work, is it? Because I've got two variables. I mean, it could work, but I'm probably overcomplicating this, to be honest, at this point. It's only 3 marks. It is symmetrical. It's got to be symmetrical about this point here. I'm probably overcomplicating it. Midpoint of 5 plus 1 of 2 equals 3. Yeah, that'll get you. Yeah, that'll get you the first one. There you go. So yes, because I've got the 2 here, 1 add 2 gets you the 3. the x coordinate is then 3. We don't know the y coordinate, but I can put 0 and 2 in and get that out. We know the y coordinate anyway, it's right there. What a numpty. So yeah, right, okay, perfect. So x minus 3 plus y minus 2 all squared equals r squared, which we could then do, well, the radius has got to be 3, so that gives you 9. Yeah, that's it, done. And then I imagine the next bit's going to be work out k. But it doesn't say anything about working out k, which is quite interesting. But you could work out k at that point, you could plug 1 in. The edge is 0 to 1, and on the other side it's the same, surely, so 5 plus the 1. Yeah, and then it's easy. I want to read that again. The edge is 0 to 1. Yeah. I like that. So that distance here, that's 1. So if you did the same thing over here, that has to be 1 as well because of the symmetry. Yeah, neat, yeet. Yeah, sometimes you can just see these things, other times you can't. And I could have ended up doing something really complicated there, which I knew it wouldn't be. I knew it would have worked, but I knew it wouldn't have been, like the right method. Right, I'm going to leave it there because I'm already 6 minutes over and I'm going to get in trouble. So, thank you for watching. I hope that was useful. Good luck, everybody. Yeah, best of luck tomorrow. And I'll do another one next Sunday, but I'm probably going to have to pre-record that because I'll be busy next Sunday. But I'll put a video out going through like paper 2 and stuff. Put any comments in or anything, and I'll try and do a stream maybe if I can another time, or maybe not do that Sunday video and do a stream maybe earlier. I'll have a think. But yeah, if I do a stream, I'll schedule it. If I do a video, it'll come out on Sunday. Alright, thanks for watching. Good luck, everybody. Yeah, bye-bye.